Hello, everybody. I got 12, not 2:01 p.m. here in Tucson, Arizona. So let's go ahead and get started. My name is Jeffrey Gillan, and I'm a research data scientist at the Data Science Institute here at the University of Arizona. I also work for this project right here, Cybers, which is a cloud computing system here on the campus of U of A. And we are going to actually do a little bit of Cybers in today. Let's talk about the main topic, which is Cloud Optimized Geotiffs. So let me share my screen here. Okay, so this is the session of NextGen Geospatial, where we are doing data science workshops all around geospatial themes. So today is Cloud Optimized Geotiffs. Let's go back to, I think I put the course content in the chat there. Cloud Optimized Geotiffs. Now let's go with home. Okay, so this is the home material for NextGen Geospatial that we have it hosted here on GitHub. I'll just put it in the chat again to make sure everyone's got it. Okay, I just posted in the chat. So that's our home material. All right, let's scroll down to our calendar, go by Carlos and I. All right, so here's our calendar. Today is February 13th. So we're gonna do Cloud Optimized Geotiffs. Click in there and get to today's content. All right, Cloud Optimized Geotiffs. So we're going to talk about what they are, how to use them, how to make them, where can you get them, kind of just everything, who, what, where, when, why, how of Cloud Optimized Geotiffs. So we're continuing the theme from last week where we talked about cloud native geospatial. This is a specific format that is a, quote unquote cloud native. So it's meant for partial cloud workflows or fully cloud workflows, there are a lot of different ways you can do it. So let's talk about what these are, Cloud Optimized Geotiffs. So we'll talk about the who, what, when, where, why stuff, and then we actually will do some hands-on stuff. I will open QGIS for a little bit. I will get into Cyverse a little bit, this data store there. And then I will open up a Jupyter Notebook and Colab where we can run a little bit of Python code to kind of demonstrate what the COG or the Cloud Optimized Geotiff does for us. All right. So the modes of getting data through the internet, or HTTP. Yeah, let's talk about the traditional model. I think we all kind of know how that goes. We've been doing it for 25, 30 years. Typically, what we have been doing in GIS and remote sensing is finding data online somewhere, downloading it to your local machine, doing some analysis right there, and perhaps you might make some analysis products and then upload them, up somewhere online so other people can get them. There's nothing wrong with this model of the download model. It works for a lot of people. We've been doing it for so long that nothing wrong with it. There are just other modalities to work more directly with data instead of bringing it to your own computer. So one kind of drawback of the traditional download is you may be filling up your local hard disk unnecessarily. If you guys have ever worked with satellite imagery, chances are you download a big satellite imagery scene and you might be interested in just a little portion of it. But then you have a 3 GB file now that you have on your local machine, which maybe you delete or maybe you just hold on to forever. So it's a great way to just collect data on your machine. So there are alternatives. So using the kind of cloud native modality here, instead of downloading directly to your machine, we can just pull in data directly over the internet into an application. You can do this right now in QGIS, you can do it in ArcGIS, you can bring it into Python, you can bring it into other web applications or web viewers. And so we are talking about bringing the entire files into memory. And I'll show you a demonstration of this in a little bit. Let's say we have a 2 gigabyte satellite image. We would just bring the whole thing over, and it sits in our memory, and then we can work with it and analyze it. And we can then save to our local disk what we actually want to keep or not. So that's kind of a step in the right direction. You get away from the download. But with large file sizes, you quickly max out your memory, and you quickly realize that this is not functional in a lot of ways. So it is a step towards cloud native, but we can do something a little smarter. We can move to the streaming. We can stream data or stream file portions. And so to counteract these limitations of large file downloads or memory usage, we can stream subsets or just pieces of geospatial data from cloud storage or wherever your source is directly into your application. So we don't have to download the whole thing. We don't have to bring the entire thing into memory. We can just give me a piece of it. So you can specify a little window or a subset or an area of interest and just bring that little piece into memory. And so it really reduces kind of the overhead of memory usage or storage space. So the file format we're talking about is a TIFF, a GeoTIFF. So a TIFF, which is tagged image file format, has been around for a long time. It's still used in kind of high-end digital photography. A lot of cameras can still output a TIFF. When I say GeoTIFF, it's a TIFF, but it's got mapping qualities to it. It has coordinates associated with it and probably map projections and datums, and it gives you the ability to bring it into a geographic information system and put it on a map. And so when digital mapping and GIS took off in kind of the late 90s, GeoTIFFs became kind of a go-to image format. And so still today, most formats I get, be it satellite imagery or drone or whatever, a lot of those end up in a GeoTIFF format. All the software programs out there can read them and analyze them and write them just fine. So they are pretty much the standard. They are generally, fairly large, compared to like a JPEG. A JPEG is usually a smaller image file size. But the GeoTIFFs in terms of storing all of the data, it seems to be the preference in science and geospatial science. Okay, so that's what a TIFF is. That's what a GeoTIFF is. So what is a cloud optimized geotiff? So a cloud optimized geotiff, or a COG, is just a regular geotiff, the same ones that we've been talking about, but its internal organization has been switched a little bit. It's been reorganized to stream over HTTP. And the way we do that is we basically have 3 major features that are baked into this COG. We take a regular geotiff, but then we add internal tiling. We add overviews, and that enables us to do this HTTP get range request. Okay, so let's go through what each of those means. So tiles. You've probably all seen this if you go into Google Maps and you like pan across the map and then you see it visualized in little squares, little bits of squares at a time. Those are tiles. And that makes rendering maps across the web much more efficient. And that's how most mapping images are served. A lot of times they have a tile server to make that more efficient and faster. And so with a COG, we can bake that directly actually into the file itself. Okay. Let's see. Overviews. If you've ever been in a geographic information system or on any web map, Google Maps, you can zoom in and you can zoom out, right? You get closer and you get further away from the ground. Each time you zoom in or out, that's a different zoom level. And there's actually a overview image already created that you can see. In GISs, I think that's building pyramids might be the term. So yeah, most local software can handle this. So that's what an overview is. And with a cog, again, we are baking in these overview images as you zoom in or out. We're baking them directly into the file format. Okay, HTTP get range request. You could also call this byte serving. You can click on that link thing, it goes to like a Wikipedia page. This allows you to get specific information and not all of it. So it's like the same idea as streaming a video. You're not downloading the whole video at once. You're streaming little bits of it at a time. And so your browser allows this to happen. So they can just go out to where the image or the data is, ask for bits of it, and get parts of it, not the whole thing. So yeah, internal tiling, overviews, and then this ability to do this HTTP get range request. That's what a cog is all about. And so a cog can then be streamed directly from storage somewhere, cloud storage, directly into an application, but just whatever pieces of it that you want. And so it's a much more efficient way to get the stuff that is of importance to you without loading up your computer's hard drive or memory. Example cogs on the internet. Let's see, Planetary Computer. I think almost all of their data sets are in a cog format, and we're going to do a whole session on Planetary Computer, I think in late March. Let's see, if I go to this thing, let's see what it goes to. So this is Sentinel-2, which is a satellite from the European Space Agency. And they have a lot of their data as Cloud Optimized Geotiffs, and they have them on Amazon Web Services. So there's a lot of data collection, data distribution type people, big authorities, governments, and stuff that are getting, getting with this cloud native stuff and putting data not just as downloads, but is also something that can be streamed as a cog. So this is just an example on AWS. Planet, which we talked about several times in this workshop series, they're streaming out all of their imagery as cogs. And so you don't have to download any of their data. You can just reach in and grab what you want and bring it directly into your analysis. Let's say Jupyter Notebook, and we'll do an example of that here in a little bit. Let's see, here's a viewer. Let's click this here. Okay, so this is just a web viewer. All right, so this is a drone image that I took some years ago south of Tucson. So it is a geotiff. It's actually a cloud optimized geotiff. And so it's sitting in cloud storage in the Cypress data store, and it's being streamed to this other server that's hosting this web viewing application, something called Cog.io. So it's just a demonstration of viewing things from one server to another. So that's a cog. We can bring it in and view it in web apps. Okay, so what applications can use cogs? Well, cogs are geotiffs, so any software that can read and write geotiffs can read and write and work with cogs. It's totally backwards compatible. So QGIS, ArcGIS, Google Earth Engine, scripting languages R and Python, no problem. Let's see, and then I have how to learn stream cogs and QGIS. So we're going to use QGIS in a moment. We're going to do 3 different kind of demonstrations here, but let's just get through this material for now. Okay, creating your own cogs. So to make a cog, which includes the tiles and the overviews of a geotiff, basically the source to do that is something called GDAL. Let's open it up. GDAL. This software is in almost all geospatial software. It's open source. It is fantastic, and you will find it in everything. So it provides the back end for lots of different geospatial GIS or remote sensing software packages, even some that are proprietary. And we have something in the chat there, or is that just me? Is that just me? Okay, so yeah, you make it with GDAL. GDAL is it's not a graphical user program. It is a command line tool. You can run it on any operating system, so you got to find kind of the correct OS and correct version, but you should be able to install it and then run it doing some commands on your command line. So if that is a little scary, it's not so bad, but that's how you work with GDAL. That's how you can make a cog. I hadn't really found any other way inside a graphical user software to make a cog. I guess everyone's just like, yeah, GDAL's got it covered. We'll let people do that. RGDAL. Yep. Okay. So yeah, someone in the room mentioned there is an R package called RGDAL, right? Okay, so that's probably a binding, meaning you might have to have GDAL still installed on your computer for that to work. Okay, I'd have to try it out to see. But they're like in the Python ecosystem, there's something called Rio cog.io, which is part of the raster.io package. And that's in the Python ecosystem. But for you to work it, you still have to have GDAL installed on your computer. So GDAL doesn't come in the library that you bring into Python. The library you bring into Python is just to be able to talk to it, the software that's already installed on your computer. So I don't know if that's the case with R. It may or may not be. I'm not sure. I'll have to check that one out. But yeah, so people have made options to make cogs, either command line or in the R or Python ecosystems. Okay, so that's what a cog is. It just rearranges the kind of the information in a geotiff to allow it to stream portions of it, subsets of it across HTTP to some application that you're working in. That's what it is. Okay, so it is 2:19. Let's go to the Cyberse data store. So we did talk about Cyberse last week. Little kind of just gave you some highlights. We didn't really go into it. Let's actually click into it, and I'll show you the data store and how, like, where I'm putting cogs in my data store account. Okay, so this is Cyberse, cyberse.org. And of course, you didn't sign up for this to work, but I'll just log in. Okay, password's already saved. Good. Okay, so it gives you kind of this landing page. Let's go to, guess I haven't been here in a while. Is there not a way to go straight to the data store from here? Data commons, discovery environment. That's what we want. The discovery environment is basically where you're going to live when you go into Cyberse. Oh, we got lots of comments. Anything I need to address?
Yeah.
RGDAL is just a wrapper function. Okay, I think that's what I was saying, is that you still have to have GDAL on your computer for it to work.
And they just retired it, Jeff.
What's that?
They just retired our GDAL from the R environment as well. So
okay, so it's now defunct.
yeah, pretty much.
Interesting. They didn't have a replacement.
Not yet, as far as I know. A lot of the like spatial analyses work within ours, kind of, I don't know. I haven't heard yet.
Okay. Well, there must be some, the people making our packages know what they're doing, so there must be some alternative, right?
I would imagine. I'm just not sure what that is.
Okay. Yeah, when it come to think of it, I've definitely used that package several times, but not recently. Okay, so here we are in Cyber's discovery environment. This is pretty much where you work. This is your dashboard when you're in Cyber's. And over here on the left, I have a menu. So don't worry about if you don't have a login yet or you're not be able to follow along. That's okay. Just kind of watch what I'm doing. If you have more questions, how to navigate this once you get a user account, shoot me an email or a message and I can help you. But a big portion of what Cypress is just data. It's a data store. It's like it's like Google Cloud storage or um, Amazon S3 or Azure Blob. It's similar, only we are non-commercial and it might be probably a little cheaper for you. Okay, so the data storage is just a list of folders, directories, just like what everyone's familiar with. And so I have a directory called cog test. Hopefully that's where that's located. Yep. Okay. So I have a cog geotiff. It's planet imagery. I just have it sitting here in my cloud storage. It's 2 gigabytes in size, so not small. And I can get a public link here. And I copy that. So that's just a link, a URL to get the data directly from cloud storage and bring it into whatever application you're in. Copy it. Let's go into QGIS. If you've never used QGIS, it's just an open source version of, like ArcGIS. But this is totally open and it's built by a community, so it's non-commercial, but it can pretty much do most of the things that ArcGIS can, only it doesn't require a license or, paying. It's just a free and open source software. So in it, I can see here, I can add that cog, add raster layer. Okay, how am I gonna do it? I'm gonna do it through HTTPS. I just put in the URL there. I hit add. So this is I'm not downloading it, but I'm bringing it directly into my application and putting the whole thing in memory. So that's 2 gigabytes that are gonna go in memory as I work with it. Again, this is live demo, so we'll see what happens. Ah, there it is. Okay, so that's the second mode of data delivery and that I showed at the very beginning. This is not downloading, we are just streaming it into memory, and then from here, I can do anything I want with it. I can look at it, I can run an NDVI, I can do some machine learning models to identify things. If you don't recognize the image, this is Tucson, this is Mount Lemmon. And what is this? September of 2020. So I collected this data or got it from Planet because of a project I had with the Bighorn fire that happened in Tucson in 2020. So that's what this imagery is. So that's one way to kind of avoid downloading files is you can just bring it directly into your application, into memory. And I have not used ArcGIS in about a year and a half. I assume you can do the same thing in ArcPro. Does anyone out there can verify that or tell me I don't know what I'm talking about? I think you can. I would assume so. Okay, so that's all I want to show you with QGIS.
I want you to paste the link.
We got a raised hand. Yes.
Hey Jeff, so
Hey.
this thing you did from Cybers, how would you do it from other data sources? How would you get that HTTP link to bring into QGIS?
Well, I guess you have to know a data source with a specific endpoint link. Where are you thinking of trying to get data from?
For example, if I want to get some later data sets from USGS,
Uh-huh.
those are really big ones, and downloading them and storing them on my external drive, it just fills it. So how
Right.
could you just use those? First, if I can see if data set is useful for my project or not, and then downloading it. How can I do that
Well,
if
it
I
would
don't
have to
like their way
start.
to?
It would have to start with the data providers, and are they making it available in that type of format? A little later, I think in a few sessions from now, we're going to talk about spatial temporal asset catalogs, which is a way to find data that's like kind of in these cloud native formats, and we can look through that to see specifically if USGS is. But yeah, I mean, it starts with the data provider. They have to make this functional for people to do, instead of having things downloadable in a zip file, or that's in cold storage somewhere that has to be brought to the surface before it's downloaded or made downloadable to the user. The data has to be just kind of hot and ready in a storage somewhere that can be hit with the URL. Yeah, Carlos is bringing up Earth Explorer. That's USGS. That's where you get a lot of geospatial data, a lot of satellite imagery. I don't know if you can do that from there. That's something I need to dig into. Yeah, what big data providers are actually offering this as a service. I hope that helps. Yeah, so this is not available for every data set out there. The download model is still viable and still probably dominant.
Thank you.
Welcome. Okay. So it is 228. Okay, we have a Jupyter Notebook example where we're going to do a little bit of Python. Before I do that, let me talk a little bit more theory here. So if I have a cog, do I still need a tile server? Okay, so the beauty of these cloud optimized formats is that they can sit in cloud storage and you can stream them out to anyone that wants it with a URL. And in theory, without any kind of server specifically. So because the cloud storage and your browser are doing all the work. But if you are distributing data in mass, if you're the USGS or someone like that, this is not probably going to work for you completely. You're probably still going to need some kind of server, another service to make it more efficient. So in terms of better performance, better scalability, if you're just a scientist in your own right and you are generating data, let's say you take satellite data and then you do some analysis on it, and now you've created some kind of value added product, and you just want to make it available for other people to get, in a fair way, then this would work perfectly for you, and you don't need any kind of tile server or anything like that to distribute it. But if you're a big data distribution center, the cloud storage, cloud native model is not going to be perfect, and you're going to have to kind of add in a little bit of firepower with servers probably. Okay, last week I talked about this as well. I'll just touch on it real quick. How are cogs different from XYZ maps or web mapping tile services or web mapping services, WMS or WMTS? And the difference is, so these things are about displaying maps on an internet efficiently. But me as the user, I just get to look at it. I don't get the data. So a cog is actually about sending you the data. And now I can take it, analyze it, do what I want with it. These tile services or these web mapping services are more about display and just showing. Someone can scroll around on a map and look at things and do it in a very efficient way. Like, when you're in, let's say, ArcGIS and you say, put on a base map. That's a base map that ArcGIS is sending over the internet, just basically in a visual type of way. I don't think you actually have the data and you can analyze it. Someone could correct me if I'm wrong, but the cog is about actually data exchange and not just visualizing things online. All right, let's do an example. So if anyone's following along, hopefully this should just work for you. Should be able to just click on this button, open in Colab. Okay, so those who have never seen Colab before, Colab is I am on a Google server somewhere. I've created a little virtual machine Google has for me, and I've tapped into it through my laptop. And so Google Colab hosts Jupyter Notebooks. Jupyter Notebook is just a coding environment that you can run through your browser. It's a simple way to do it, simplest way to explain it. And typically it's Python. It could be Julia or R, but most times I've seen people do it. It's generally Python. So that's what Google Colab is. So this is cloud computing. From my laptop, I've tapped into Google's little virtual machine here. I'll connect. And once I connect, I get some resources. So what are my resources? I have disk space. So that means I can download to my Colab account, I guess, data. I've used 26 of 107 gigabytes. Okay. And then my RAM, my memory, I don't have a lot. I've got 12.7 gigabytes of total RAM. So they've given me like a little computer that I can use to do some analysis, which works for a lot of things, especially demonstrations like this. It works fantastic. It's really great for teaching. If you're doing more like hardcore analysis, you should probably not use Colab, and instead you should use Cyverse, because Cyverse does similar things. You can launch a notebook or you can launch many different applications, only you have a giant storage space and you have way more resources in terms of CPU, RAM, and even some GPUs. Okay, so this Python notebook is going to do a few little demonstrations of cogs. We're just going to bring in data in a few different ways. And, to me, this really helped when I was developing this. It helped me understand the concept of streaming portions of the data. Okay, first thing we're going to do is, so we are connected, we're ready to roll. And I'm going to just start clicking through my lines of code. First thing I'm doing is installing the library that we're going to be using, which is raster.io. And I put this -- quiet. Thanks, Carlos, for showing me that. It just makes it so it doesn't just spit out a bunch of responses that I don't, care to see. So we've installed a package called raster.io. Okay, and then I'm going to bring some packages into my environment, load them up, and that includes raster.io, and that includes a few other kind of tidbits or like other kind of little components of raster.io, which is the plot in the show. We're going to bring in matplotlib, which has already been installed in Colab. It's just stock, it's just there. So I just need to import it in, something called requests, and then a package called numpy. So we're going to bring those all in. All right, next thing we do is define the URL of the cog. So like I was showing you guys in Cyverse. Yeah, so here's my data storage. Here's my planet satellite imagery cog. And there was the public link. So we're just going to take that public link and we're going to plug it in here. We're going to call it cog_path. Okay. So now that I have the path, I want to get some basic information about this cog. I'm using the raster.io package, so don't get hung up on like all the little intricacies of the code I'm writing. That's for you guys to look at later when you have more time to kind of sift through it. Instead, just focus on the comments and essentially what are we doing with this block of code. Okay, so I'm going to get some basic information about the cog. All right, it told me it's a GTIFF, a geotiff. The data is a unsigned integer 16-bit. Good to know. It gives me how many cells are in that array. 18,000 by 15,000. We have 4 bands. That's what count 4 is. This is the coordinate reference system. So that is a UTM coordinate, or Universal Transverse Mercator. It's just a coordinate system like like latitude and longitude, but not. It's an alternative. What else in here? Tiled equals true. That might be of interest to us, because remember we learned that cogs have tiles. Okay, that's just some basic info. And then we have this block of code. Took me a while to figure out, to retrieve the file size of this cog. That's something you might want to know before you bring it into your notebook, is like, how big is this file? Okay, file size that's 2 billion bytes. In translation, that's 2.19 gigabytes. A gigabyte is more, it's a million bytes, 10 billion bytes. Yeah, it's a billion, I guess. Yeah. A gigabyte is a billion bytes. Does that sound right, Carlos?
Actually, no.
No, then what?
Well, 1,000 is 1,024. 1 million is
So is this incorrect?
Maybe.
So this is, yeah, the
just
the
for practical purposes.
it's
in
2
order to-
billion bytes, and I know for a fact this is 2.1 gigabytes. I don't know. The number sounded big. We'll have to sift through that and see what's wrong. Anyway, you can use that to get the file size. Okay, and then I have this little code block here saying trying to identify, is this a cog or not? And so it's going to reach into my URL and then see if is it tiled and does it have overviews. Let's run that. Okay, yeah, tiled equals true. Yes, it has overviews. Okay, that probably means we have a cog. All right, and let's go through kind of 3 different ways of bringing data into use. The first one was the download method. Let's see, it's 2:38. Okay, we get through this. We did this a couple weeks ago when we did Planet APIs. So with this block of code, we can just download the data from my cloud storage in Cyvers and download it to my storage here in Colab. Okay, so let's just do that. So this is 2.1 gigabytes. And so whenever I do things, I like to look at my resources and see what's going on. Is it using memory? Is it using disk? So yeah, I'm downloading the data into my temporary cloud instance. So keep in mind, Colab is really great for demonstrations, but it's not a permanent place. In a day from now or less, that data that I downloaded will just disappear, as far as I know. Okay, you can see the RAM has gone up a little bit, the disk space has gone up a little bit, and here I have it. Here's my cog example. It's now been downloaded. Yep, I have it. So that's the download method. It works. And then once it's downloaded here, then I can work with it and analyze it if I so choose. Yeah, our message was cog downloaded successfully. I love these little messages that you get. Okay, so that's one way to do it. This next one is the second method, which is from cloud storage, I can read the cog into memory, but not download it to my disk. And so large files require a lot of memory. Let's try that one. Okay, watch the memory here. This also might take a little while. Oh, it's jumping 4.5. So once I hit 12, it's going to crash. It might crash before 12. 5. Yes, we're also testing Wi-Fi internet speeds here at the library. Wow, yeah, this one's taking a while. So this doesn't appear to be the most efficient thing to do. Let's give it a couple more moments and then we'll move on. 7.8. Okay, it's
You always have the swap memory, which is twice the RAM.
say that one more time. Say it to the class.
In Linux systems, you have the swap memory, which is twice the RAM. So it's a working memory. So probably the rule of thumb, the system can work with 36 gigabytes.
Really? Okay. Interesting. I've actually crashed this several times trying to do similar things. Okay, so what did it do? It read that satellite image into memory, and then I had it display just the first band, which I believe is blue. And so that's what we're seeing here. If I would have displayed all three bands in like a color image, it probably would have crashed Colab. So these are big file sizes and it uses a lot of resources. So that's the second method, bringing a full geospatial data product into your environment. Yeah, you can do it that way. A different way, let's just let's restart things. So let's like clear off the memory and everything. Runtime, let's restart the session. Okay, and look at my resources. We're back to kind of square one here. Let's install. We gotta click through things again because we just restarted everything. But it'll only take a moment. So let's bring in or install that raster.io library. Okay, let's import the libraries we want into our notebook. Great, let's declare where the cog is that we're getting it. We're getting it from Cyber's data store. Okay, yeah, we can get the basic info again. All right, we don't need to do the rest. So let's go down to our different way. So this third way of getting the data is the cog way, which means we're going to bring in a subset. And so instead of downloading or bringing into, the whole image product into memory, we can just get a subset. So this code here is defining that little subset. We're making a window. We're making a bounding box in geographic coordinates. These numbers here are coordinates in universal transverse Mercator. Okay. Yeah, that's all we really need to mention. I'm just saying, hey, get that cog out of cloud storage. Only give me this window here. Don't give me the whole thing. Just give me this little box. Okay, and so it did it almost instantly. And so this was enabled because the data product that we have is tiles and is overviews. And so I can just boom, I can just get what I want and not have to use a lot more resources. Okay, so then once we have our little subset, so this is Summer Haven. And so this is at the top of Mount Lemon. And we got a raise hand. Go ahead with your question, please.
Jeff, so how do you find out what is the coordinate system used in the card? And how do you make sure your specified coordinate systems or the corners are consistent with that coordinate system?
Okay. To figure out what the coordinate system of the cog is, you use this feature here. I did this like get basic information about the cog.
Mhm.
It is telling me CRS is a coordinate reference system. And it gives me this code called EPSG. And that, I don't know I forgot what that stands for, but that's just like a standard in terms of every single coordinate system and projection and datum has a unique number. And so that 32612, let's see here. Let's get EPSG. Okay, yeah. So I just have to Google it and I get WGS84 and that's the datum this is the coordinate system, which is UTM zone 12 north.
Okay.
Yeah, it helps to have familiarity with coordinate systems and datums and just kind of know that world of cartography a little bit.
Okay.
Then how do you find out where the bounds are? You got to go into a mapping application like QGIS or Google Earth, is one. I go into Google Earth and then I can just find my area and like just look at what the coordinates of the cursor says. And that's how I got the bounding box in this this example here as I use Google Earth.
Okay, thank you very much.
Yep. Okay. Back to our little portion, our cog here. So it's a much smaller area of interest. We've basically used no RAM to get it, no disk space. So it's just a lot more efficient to just get the area that you are interested in, bring it into your analysis environment, and just forget about all the other stuff. And so once I have it in, then I can, let's display it in red, green, blue, just so it looks more normal to us. That's what this entire giant code block is. It's just doing this. So this is RGB or red, green, blue composite of Summerhaven up on top of Mount Lemmon. Okay, and then I can do any kind of analysis. So I'd like to calculate an NDVI with that planet imagery. So this is 4-band satellite imagery. Band 4 is near infrared. Band 3 is red. So those are the bands you need for a NDVI. So let's click that code block, and that should then make a NDVI for us. And so, yep, that's the normalized difference vegetation index for my little area of interest in on top of Mount Lemmon outside of Tucson here. And so, yeah, that's pretty much all I had with the Jupyter Notebook. Just show you different ways. One way to download, another way to bring the whole product into memory, or the COG way, which is just grab a little area of interest and bring it into your analysis environment. And it makes it more efficient. So if you were doing a lot of processing and, you can just grab pieces from here, work directly with it in the cloud, and just kind of skip downloading, large files to your hard drive, which you probably won't end up using. And so, yeah, that's a cloud native workflow. So, does anyone have questions? Yeah, that's a cog. It's hope that was simple. It's when I was trying to figure it out, it wasn't so simple. And so my goal is to really make things like simple, because most of this technical stuff is vocabulary words and fancy technical terms, and I'm trying to demystify a lot of that. And it's like, no, these concepts are not that hard. It's just, there's a impenetrable layer of tech sometimes. So I will stop my share. And yeah, that's what I have. It's 2:49 by my time. Is there any other questions or thoughts about cloud native geotiffs?
I have a question, Jeff.
Yeah.
So here we use a Jupyter Notebook. Can I replicate these codes on my system, like on command window? Can I do that?
You would like to have this code? What you're saying?
No, like the lines that you type, can I replicate them on my system? Like if I just have a command window, can I just replicate them on my system? If I don't want to do it on Jupyter Notebook.
Sure. This doesn't, yeah, you can run the Python on your own local machine. Yeah, absolutely. It just doesn't give you this nice visuals that, instant gratification visuals. But yeah, you can run your Python code in the command line of your local machine through, a integrated development environment like VS Code or, anything. Yeah, it's Python code, so it can be ran anywhere where you have Python 3 installed on your machine. Okay. And Carlos pointed out something useful. Is that in where is that file?
Google Colab.
Okay, so yeah, if you look, oh, I'm not sharing my screen. share screen again. Okay, can you guys see my collab? So you can take what I've done and you can get a copy of it. So you can save a copy of this notebook, or you can just download the Python. I've never tried that. That's kind of neat. Let's see.
It will strip up all the comments.
Yeah, awesome. Okay, well, here it is. Yeah, you just download just the Python, and now it's brought it into my IDE VS Code.
Great, this is great. Thank you.
Yep. Okay, so next week we'll continue with this cloud native theme, and we'll do cloud optimized point clouds, which is the same idea, only we're working with point clouds that you've that are created either through LiDAR or photogrammetry. And I'll show you different examples of how to stream it into applications. And I'll probably look at some, show you some new kind of like, well, new to me Python tools for how to analyze point clouds, because most of my work has been in R. So hell, I don't know what I'm gonna do next week. Maybe it'll be R, maybe it'll be Python. I'm not sure. I'll do something. So that's what next week is. If there's no other questions, then we can just we can stop here.